Hello everybody and welcome back. Well, we have our next victim here on the bench. What we have is a Pioneer model SA9100. Now some of you may remember this from an earlier video from a while back called the old married couple. And what we're going to do on this video, this is another troubleshooting video. This has developed a problem where it's probably going to end up being an intermittent transistor that's either leaky or shorting, and it's intermittent. So what I want to do in this video is kind of take you through the process of identifying the failing component. See, this can be difficult sometimes because when you have an intermittent problem like that, you can't always see it if it's not doing it, and even when it's doing it, the circuit will be active. Now, sometimes this thing apparently will go into protect mode and stay in protect mode, but other times it won't, and it'll just make noise. You'll just hear cracking and popping and static and all kinds of things. And our challenge now is to try to locate the failed component or components, whatever the case may be. Now, that can always be kind of tricky on these, because when you troubleshoot these things, you always run the risk of a component that's on the brink of failure like that. If it totally fails, these are direct coupled circuits, which means one transistor is directly connected to the next. There's no isolating capacitor for isolating the DC between the stages. So if you short one transistor out, that short can affect other things either up the chain or down the chain from where it's located, and can cause other things to fail. So you have to be careful how you approach this, because you don't want to cause more damage by running it too much, but in the same token you have to leave the amplifier on so that you can test it. Some amplifiers do not have a protection circuit like this, and if you have speakers connected while you're testing it and it goes full short on you, guess what? You're going to put solid DC on your speakers and destroy them. So once again, you have to be careful. Now this one has a relay, and it has a DC sensing circuit, so that if the speaker terminals see any kind of DC on them, the relay will disconnect the speakers from the amplifier. It doesn't mean that you don't still have the DC there. It just means that the relay is preventing the DC from connecting to the speakers. So if that sounds interesting to you, stay tuned. We're going to do this, and we'll kind of go through kind of one of my processes of how I do that. Now remember, in our previous video of the Carver M500T, we used one method to locate some shorted transistors, but we're going to use some different methods now for looking at our intermittent transistor. So let's see what we can find. Okay, so we have the amplifier connected to our dummy load resistors, and we have the scope monitoring the output of the resistors, and we're looking at channel 1 and channel 2 together. And I have just like a 500 millivolt sine wave, 400 hertz sine wave into the auxiliary input. So let's turn the volume up on the amplifier, and so far it is not in protect mode, and let's see what it does. So you can kind of see we're getting a nice clean signal, albeit looks like one channel is a little bit different than the other, but this cheap oscilloscope here, the PC based oscilloscope, is notorious for doing things like this. It's not always perfect, but it works pretty well. But as you can see, we have a pretty clean all the way up to clipping. Looks pretty good. So actually it looks like maybe the two channels are not perfectly balanced as far as gain, but everything's working just fine. And I'm on the ×10 on my scope outs, so it's really 10 volts per division as far as peak to peak goes. So we're putting quite a lot of power into those dummy loads right now, and it's working fine. So I'm going to let this kind of cook at about maybe 10 watts or so per channel for a while, and just see if we can get this transistor to fail. Okay, so I tried all the other inputs and it's basically the same thing. So the only thing we haven't tested now is the phono stage. And I do know when this thing failed, it was actually listening to a record player. So maybe it's something in the phono stage. Again, the phono stage in these is pretty good quality, but those transistors have been known to fail. So let's see if that's maybe what the problem is. Again, I've not seen the protect come in or anything, and I did when listening to it, it did it. So, you know, when it was actually connected up. So whatever it is, it's very intermittent. So I'm going to show you a little gadget here. To be able to test a phono stage, the input of a magnetic phono stage in a normal amplifier, the input impedance is usually somewhere around 68K or 68,000 ohms. And it's a very high gain circuit when compared to a line level input. So your input signal has to be very small, smaller than a lot of signal generators are very comfortable with doing very well without noise and so forth. And you also have to deal with that impedance mismatch. So I'm going to show you a little gadget here that kind of makes that a little easier to deal with. And all this is just a little adapter. That you can make a homemade one, but you can buy these online. And this is basically a reverse RIAA adapter. So what does this do? Well, it does two things. Thing number one that it does is it will reduce the signal, you know, of your signal generator by either, and it's switchable, by either 40 dB or 60 dB. So it'll actually it'll attenuate at negative 40 dB or negative 60, depending on where the switch is. I keep going off camera. So you could see that. The other thing it does is these filters in here essentially cancel out the RIAA curve that's built into a phono amplifier. Now, the RIAA curve, that would be another whole video if we get into what that is. But it's essentially an equalization curve that is built into the phono preamp to kind of decode an encoding that was put onto each record when records are being pressed to smooth out or equalize the sound. And it has to do with how a phono cartridge picks up the audio from a record groove, and how its response on lower frequencies is different than its response physically on higher frequencies. So that circuit is designed to equalize that out. What this does is this cancels that out and makes it linear again, because you're not putting a record player into it, you're actually putting a linear signal generator in there that has a linear signal output. So this is a reverse RIAA adapter with attenuation. So for a magnetic phono cartridge, if you wanted to simulate a magnetic cartridge, you would have to put a negative 40 dB attenuation. And for a for a moving magnet cartridge, I'm sorry guys, you'd be in this position. And if you have a moving coil cartridge, you actually would put it into negative 60. So that's pretty much what it is. Okay, I just turned it on and look what's happening. Literally, I just hit the record button, and as I hit the record button, the protect relay clicked, and you can see we have one channel kind of going doolally on us right now. If I turn up the volume, you could see, look at that. It goes crazy. And there we're in protect. So with the volume all the way down, it looks like one channel is causing all of our problems. Now, again, we haven't taken any covers off this amp yet. If it's one channel that's causing all your problems, then we have already kind of ruled out the power supply. This is a single power supply amplifier, meaning one power supply feeds both the right and left channel. So if only one channel is affected, then we can pretty much decide that it's not the power supply, and rather it's a transistor. Look at that. It's a transistor in the one channel. Now let's switch over, just out of curiosity. I have switched over now to the auxiliary input. I've kind of gotten the phono stage out, and it's still doing it, see? So now that rules out the phono stage, because you can see it's still going crazy, and we don't have the phono stage even connected now. We actually have the auxiliary input connected. Okay? So now we know it's not the power supply, and it's not a transistor in the phono stage. So now it has to be either in the amplifier stage, or it has to be in the preamp or line stage or tone control stage, something like that. Now, normally, just from experience, especially on Pioneer amplifiers, this is usually pretty telltale of a small transistor in the driver section or pre-driver section. Oh, we're in protect mode now, and it's locked in. Nope, just dropped back out. Now it's back in. So we could see down here what it's doing. See if we can get this all in shot. See it? So there's your protect. Now it dropped out, and watch the scope, what's happening. And again, if you notice, there's some pretty radical signals going out that speaker terminal before the protect circuit kicks in. This is why you don't want to do this test with actual speakers connected. To see those gigantic peaks going into your speakers, very high probability it could damage the speakers, or at least damage the tweeters. Those sharp impulses like that, not a good thing. And you can see we're connected to the auxiliary terminal, and I have the volume all the way down. With the volume all the way down, that's basically saying that it's probably not in the tone amp or the line amp section. It's going to be in the power amp section, because this volume pot actually kind of cuts out the signal to the between the line stage and the power amp stage. So without even taking the covers off, and just by doing a little bit of testing with a dummy load resistor in our scope, we've pretty much already narrowed it down to the right channel, and it's the right channel power amp stage. So now we've only got a few transistors that it can be. So let's get some covers off now that we know, and we're going to look at it a little bit more carefully, and we know where to start now. Okay, so we know it's in this channel, and it's probably one of these little transistors down here. So what I'm going to do is I'm going to actually spray one of these things with, basically I'm just using dust spray, like for your computer keyboard. And if you turn the can upside down and just use the propellant, it actually works as freeze spray. And it's a really good troubleshooting tool. And you can get it in pretty much any kind of office supply store or whatever. And what we're going to do is I'm going to go for these silver cans first. They get really, really hot. These ones here and here, they get really, really hot. And a lot of times, those are the ones that'll cause problems. So I'm going to kind of get the camera here at an angle that hopefully we can see everything. And we're just going to go, and it's working right now, and it's not failing. Some components fail when they warm up. Some of them fail when they're cool, and they fix themselves when they're warm. So really the only way to troubleshoot this is you let it run long enough to get nice and warm, and if it doesn't fail, try to cool it down and see if it fails. So we're just going to go ahead and shoot a couple of these with this stuff here. Okay, let's start with this one here. Just give it a little shot. And see, we got a little jump there, but really nothing else. All right, let's do the other one. Nothing. Let's do the drivers here, the big, oh, look at that. It's in protect. Let's let it warm back up and see if it comes back on. So this is the part that kind of takes time, guys. There it is, it popped back on. So now what we need to do is we need to go in and check some voltages. So we kind of understand where the problem is. Now we need to be able to get in here to check some voltages. One of these transistors, and I bet it's one of these silver ones. See, I feel them warming up again. One of these transistors here warming up, okay, kick back on. You could see, but this channel's pretty much dead now. It's just got all kinds of noise and stuff right on the brink. So one of these transistors, and there, now it's on normal again. So here's the challenge is, now while it's in a failed state, you really can't get to it without taking the whole amplifier apart. You need to decouple this board to be able to see it. One of the things I noticed, let me zoom you in, that makes this particular amp a little bit of a challenge to troubleshoot is, look at that transistor right there. And you can see, and this is an original factory transistor, it's got like a plastic cover on it. So you can't really get your meter down in there to check it. You actually have to check it from the rear, which you really don't want to be poking a probe back there because it's too easy to short something out. So unfortunately, this is not going to be easy to measure with the meter without taking the heat sink out. And unfortunately, shutting this down is going to let it cool back off and restabilize, and we're going to have to go through the whole process all over again. Okay, so after a very long, drawn-out process of patiently waiting, I was able to find that the voltage on this little transistor here was moving around, this little 2SC1451. And if you recall, this is one of the two, these get really, really warm. The other ones on here stay relatively cool, but these two run hot, and that's normal. They do normally. Unfortunately, I can't show you that because I spent the next 20 minutes trying to get it to do it again so I could hit the camera and record it, and it fixed itself. So intermittent transistors will do this from time to time. But it is this one. You'll have to trust me on it. I'm not going to waste any more time waiting for it to fail. We pretty much know what it is. Another thing I noticed was this amplifier board here, besides being recapped, has had a couple of transistors already replaced. And that's these two little ones down here. You can see there and there. I don't know if we can get the camera in there any closer or not. But if you look at them, they are replacements. If you'll focus, it's kind of hard. Right there. It's these little guys down here. And if we go to the other channel and look at the original ones that were in there, you can see these are little metal can type transistors down here. These are the original ones. So these were actually replaced at one point in time. Again, I don't believe I changed them. This is my amplifier. I've had it for a long time. But the only thing I did was a basic recap. I really didn't touch anything else. It was perfect. And this amp has been working for a long time with no problems. But what I will probably do is I will replace the pair of these transistors here. I don't think I'm going to do much else to this because it's working so well. I'll just replace these two 2SC, what are they, 1451s. And we'll test the amp out and see how it works. Okay, we have our transistors replaced, and here's our old, what were they, 2SC 1451s. We'll pull those out. And we replaced them. You can see down here, there's one there, and there's another one right here. And those are KSC 3503. They're good replacements for these. They work well, so that we shouldn't have a problem. The other thing, while I was in there, I looked at those ones that were replaced before, and they had replaced them with two SA 1015s. You can see right here. And so they had been replaced. Looks like these are older transistors, had been replaced a good while ago. So what I ended up doing was I replaced them, since they had already been replaced before, with a new pair of KSA 992 FBUs. So that's KSA 992 FBU, and that's those ones that are down in here. Just replace them for good measure. Other than that, I didn't replace anything else. Again, this is just a repair video. If you want to see like a more detailed restoration video of one of these, I did do a video series called Restoring the Old Married Couple, and it was on an SA 9100, just like this one, and a TX 9100 tuner. And that's way back, but if you go back in my videos, you could see it. But this was just really a video to show you how to troubleshoot an intermittent problem, especially when you have an intermittent transistor. Intermittent transistors are pretty common on old gear like this, and you run into this from time to time, and you get the thing on the bench, and you realize that it's not failing. And then when it does fail, it fixes itself before you can actually troubleshoot it, and it can be very frustrating sometimes, but you really just have to go through the process. But if you notice, we had it almost the whole way narrowed down to this little board here just by looking at the outputs and kind of paying attention to the symptoms before we even took the covers off. And that's kind of the process I wanted to take you through on this. So I hope you enjoyed this video. We're going to flip this over right now and do one last thing. We're going to check the bias. And the reason I'm going to put this at the end of the video is that you'll notice whenever you replace these transistors, even though you're using good quality replacements, they are still going to be different than the originals a little bit, and that may cause some issues. The bias on this, if you follow the procedure, should be at about 25 millivolts after being on for about a half an hour. And my guess is that it's going to be either too low or a little bit, probably it may be a little bit too high. I'm not sure, but we'll find out. We'll connect up the meter and check it, and then we'll make the quick little adjustment to it, and we'll end this video. Okay, as you can see, I'm on the two test points here for the bias adjust, and it's all in the service manual. I went over this, I think, on the previous video. So we're going to look and see if we have our 20 millivolts or 25 millivolts, I believe. So here's our meter, and let me turn the power on, see if it comes out of protect. There's the click, so it came out of protect. And as you can see, we're actually low, not high. I thought it was going to be a little bit high. Actually, it's a little bit low. So what we're going to do is we're going to let this thing warm up for a while. This will continue to creep up a little bit as the transistors warm up. Once we get it stabilized, we'll see if we get our 25 millivolts. I have a feeling we won't, and at which point we'll go ahead and we'll make the adjustments, and then we'll call this one fixed. Okay, I just missed the part on it to getting it on recording it where I actually adjusted the pot. But basically all we did was, if you remember, it was sitting at about 12 millivolts, and all I did was just gave this a tiny little turn down here till it came up after it had been sitting for about a half an hour, and brought it up to the 24 millivolts or 25 millivolts it needed to be at. The next thing you want to do is you want to put your meter across the speaker terminals with no load on it, so no dummy load, no speakers or anything. And this pot here is for adjusting your DC balance, and all you're going to do is set that till you have 0 volts on your speaker terminals. Again, this whole thing, I think I went through this on the last video, so I'm not going to repeat it. So this is all done. I'm going to put the cover on it, listen to it for a while, make sure our problem is solved, and if it is, we're done with this project. Okay, I've been playing the amp through the auxiliary inputs here for about half an hour or so. I just switched it over to the phono inputs, and we're just using the reverse RIAA adapter. And I'm playing through our phono inputs. I just want to make sure I got all my bases covered before I take this off the bench. But everything's playing well. Yep, playing good. A little bit of Johnny Cash going on there. And so anyway, it's playing really well. So I think we fixed it. We found the bad transistor. Turned out to be one of these little guys here. And just a repair. Again, kind of hope you can see how much patience you have to have when it comes to waiting for these to fail and kind of tracing it down. Again, you know, you can go shotgun it and replace all the components in there, but that really wasn't the point of this video. This was the point of learning how to troubleshoot and narrow down to an individual failed component. It's kind of an exercise in that. I hope you enjoyed it. I know I sure did, and if you notice, my voice is a little bit different. I shot this video actually over the course of about 2 weeks because things have been so busy at work and so forth. So it took me a while to get this finished. If you notice, I've been posting videos as much lately. So anyway, we're all done. I wish you all peace, joy, happiness, and good health in your lives. I thank all of you who did send some donations over the last month. I really appreciate it, guys. I don't know how to thank you. I really, it's wonderfully kind of you to do. As always, I promise I'll use it only for things for the bench, for videos. And I'm glad I can help you guys out. And you sure have helped me with the comments. There's a lot of things that I learn from you when you comment. So please feel free to do it. And again, we'll see you next time. I already have my next video planned, so I'll be getting started on that as soon as I get this off the bench. And until then, I hope you all take care. Have a great day. Bye-bye.